Hello everybody, welcome to SUSE Digital. I'm here to talk to you today about openSUSE MicroOS, the desktop, and why it is the perfect platform for developers in the SUSE ecosystem. So first, a little bit about myself. My name is Richard Brown. I work as a software architect working on distributions inside SUSE. I've been doing this open source stuff now for like 15 years or so, 9 years of that with SUSE. In the past, before then, I was actually a SUSE customer, so this is definitely not my first SUSECon. And I've been a QA engineer, been a distribution and release engineer, shipping various openSUSE and SUSE distributions. I've been in the openSUSE board, etc., etc. And of course, with all this Linux stuff, I've been a Linux desktop user for about 20 years now, and I created this thing called the MicroOS Desktop, which is what I'm going to be talking to you about today. So for the agenda, I'm going to start by talking about the MicroOS mindset generally. So, all these micro operating systems that we now have in the SUSE world, what mindset you need to approach using them and kind of get under good understanding of where we're coming from. Then I'm going to talk about the MicroOS desktop in some detail. Then FlatHub and Flatpak, how we use them, why we use them, why they're good for doing desktop applications. A little bit about DistroBox and the role that plays in everything. Teeny bit about transactional update, and then finishing with the current future for the project. So, starting off with the MicroOS mindset. Linux is an awesome platform. Been using it for 20 odd years. It's wonderful, it's great, and some of the key reasons why it is so good is that it is extremely customizable. It's extremely multi-purpose. Whatever you need it to do, it can do. You can customize it to do everything. And then once you get it out there, it is, an incredibly reliable platform. But unfortunately, like looking at it now with sort of fresh eyes and being somewhat critical of the whole thing, these same attributes that make, generic Linux so awesome are also some of the most terrible things about Linux. Looking at it from a support point of view, that customizability makes every single installation different and contains untested and untestable combinations of software. We there's no way in a million years that us as distribution builders can possibly think of every possible combination out there when there's 15,000 packages and users can easily pick all of them and none of them or whatever. So that customization really actually makes it an incredibly hard platform to actually support and maintain and to keep updating and make migrations work smoothly, etc., etc. And that multi-purpose element of it, the fact that you can have, a server that is also your desktop and, potentially also working in the edge as a VM all at the same time, like, practically speaking, no one's ever going to do all of that. But the fact that technologically speaking, we've enabled a platform that can do that actually makes it really quite complicated again to, do a wonderful polished experience in any one of those scenarios. If you've got to customize your software that, it's got to work perfectly in the desktop and a server at the same time, is it going to be a good server platform? Is it going to be a good desktop platform? Probably not. You're probably going to end up having to compromise on both. And that's, the sad reality of a lot of Linux out there is it's not as good a server as it could be, and it's not as good as desktop as it could be. And then, reliability, yes, Linux itself is incredibly reliable, but having all these different combinations, having this sort of broad, undefined multi-purpose scope means that, anything installed at any time can totally change the behavior of the system, maybe in a way that was intended, maybe the way that wasn't. And then, when it isn't, sooner or later you notice the thing's misbehaving or behaving differently, then all the hassle of debugging, figuring out when did it change, how did it change, etc., etc. This is Edmund's curse. Linux doesn't really do anything to lighten that. It in many cases makes the situation worse. And when talking about this, especially in the community context, lots of people harp on about how Linux is all about choice, and open source does in some ways bring this kind of freedom of choice. You can always develop something different in the open source world if you're not happy with what's already there. But Linux, at its heart, the operating systems in their heart are not about choice. It's about good engineering. What should be the priority for us as operating system builders is making sure that we're making those hard choices for the user, figuring out what they want and what needs to be done best for what they want, and focusing on making the right choice for that. And in some cases, that means not offering a million billion choices. We're not building a Lego set, we're building platforms for doing stuff. And that's where kind of MicroOS, or in the SUSE enterprise world, SLE Micro come into the scene. The idea of looking at Linux with a fresh pair of eyes and coming up with a platform that is 100% predictable. Once you have deployed that thing, it is not altered while it's running. While it is running, it is exactly the same state as it was when it started booting that day. So no libraries changing, no misbehaving binaries can get added mid boot or while the system is running. It's going to keep on working that way until you change the state to a new state, and then you know exactly that you've gone from state A to state B. And if state B doesn't behave the way it wants to, you can always go back to state A. So everything's running consistently on every single boot. And if this inconsistency gets introduced, you can track it, resolve it, fix it. Part of all of this is also doing all of that at scale, avoiding the need for individual configuration as much as possible, trying to be like the zero effort platform, have all the instances configured on first boot that one time, set it and forget it. Yes, you can modify things during runtime if you really need to for configuration, but the MicroOS mindset is one where, that should be avoided as much as possible. And, again, kind of in that same mindset of narrowing the scope of, Linux, instead of being a do everything to doing just one thing. Each instance of MicroOS is really focused on this idea of it's there to do just one job. That job could be your mail server, that job could be a container host, which could then, as a container host, run many other things. But the job of the operating system is to do one thing. Be a container host. Everything else after that is out of scope of the operating system, not the operating system's worry. If you're, just like you wouldn't, the operating system shouldn't worry about what you're putting on top of your mail server or your web server. It shouldn't worry what containers you're running. The operating system takes care of itself, and then you, as a sysadmin, can just worry about the workload you're putting on top of it. And then reliability, making sure that if there are any issues, like I already mentioned, you've gone from a known state to a known state. You know exactly what was introduced in each of those states. So if there are any issues, there's automatic recovery from any of those faulty updates. Now, MicroOS is based on openSUSE Tumbleweed, the rolling release in the openSUSE family. So, we're doing all of this at speed, keeping up with upstreams. It, in fact, it's quite remarkable how fast this moves, but, we have a very large community and lots of people working on it. And yeah, with MicroOS, you've got that platform doing all of this at the pace of the entire open source community, which is, really quite nice. And because of that, in my view, from a community server operating system perspective, it's the perfect platform for if you don't want to pay for your Linux, if you're not needing support, if you're not needing maintenance or all of that. MicroOS based on Tumbleweed is the best way to go. Minimizing the problems, keeping up with the open source community, so you're always getting the updates as fast as possible. You've always got more help there than the alternatives. If you're doing community Linux, this is the way to go for the server side of things. And this has been the inspiration for Alp. It's also been the inspiration for SLE Micro. while the Alp family of products is a family of products, and it'll be having variants that I'm sure that do not follow this mindset. Alp Micro coming soon, has micro in the name, right? It's borrowing from these ideas and learning from them, and then many of these ideas will carry on in some form or other to the other Alp family products also. But that's the server. What about the desktop? Well, desktops are special, not just because it's something that we actually physically touch. So they need to be really inviting and reliable, and it's not like a server which you can just hide away in a server room and yeah, don't touch it unless you really really need to. They can't be hidden away, and you can argue that when something goes wrong with a desktop, it can be for some people, for many, in fact, be more disruptive than if a server goes down. Servers can have high availability. Servers can run in clusters. You can always have a backup instance somewhere else. Not that many people have two laptops lying around in case one goes down. So, it has to be as reliable for that individual, or if you're rolling out a fleet of them, has to be that reliable for your entire fleet. Any problem on a desktop is a huge issue for someone involved. So, a couple of years ago now, as I was working on MicroOS, and thinking of that general MicroOS mindset, I was like, well, I want a desktop that kind of embodies these things. So I started this MicroOS desktop project, taking initially those same concepts of reliability, predictability, immutability, just like regular MicroOS, but also then figuring out actually how to make this as like a damn good desktop operating system. So being a bit opinionated, we're primarily supporting GNOME. There is a KDE variant, but reality, most of the community is there with GNOME. GNOME is better aligned with a lot of these concepts, especially when we're aiming for something that is much more like a Chromebook than, let's say, a regular Tumbleweed or openSUSE Leap desktop. We're not looking for all the customization. We're not looking at offering all the options that you could all possibly have. Custom partitioning and picking different patterns and all that kind of stuff. We have the luxury here of building something new, being opinionated with it, and so coming up with the best choices that we can for the GNOME environment and making sure you get that. That also comes with the benefit of bringing a system that is small, or smaller than a regular Tumbleweed installation, but not at the expense of functionality, right? Like desktops, right? You need these basic things to work. You need your printing to work. You need your gaming to work. You need your media production and your streaming and recording conference videos like this. All of that has to work, and ideally, all that has to work straight out of the box. So with the MicroOS desktop, we've really taken that on of like making sure that as much as possible, everything works straight out after the first boot. And yeah, where we can, we answer all the questions that we can as part of the installation. So, the user doesn't have to do anything. And then for those questions that we can't answer as the distro builders, we can make sure users have nice, friendly dialog boxes, wizards, etc. So on that first boot, it's for example asking for your username, your password, locale settings, that kind of thing. So once you've got that through that first wizard, you shouldn't need to be doing any more to actually get to work, and you shouldn't need to be adding repositories and customizing software sources and all that kind of stuff. And so, as an example, here is my current desktop, which I'm using to present to you. It looks an awful lot like any other GNOME desktop. But yeah, that's kind of the point. It's not meant to be, the shiniest, fanciest, most customized one. We're staying close to upstream. We're working very close with them. But it's a GNOME desktop. It's a modern desktop. You've got all your applications along the bottom there. And talking about applications, the architecture for the MicroOS desktop looks a little bit like this. So, starting at the bottom of the slide and working up, we have a base operating system, which, as you might have guessed, is MicroOS. And on top of that, in the base OS, we also add GNOME without applications. That's a bit of a simplification for the slide. In reality, there's a small subset of applications that we include, things like a terminal and, the GNOME settings, because you've got to have the settings application to be able to configure the thing. But basically, the minimum applications, just enough to get things running. For example, there isn't even a browser in there. Avoiding the right-hand side of the slide for the moment, the next in the stack is the graphical applications. And primarily for the MicroOS desktop, that means Flatpaks from FlatHub, which I will go into more detail later. But for example, as mentioned, there isn't a browser in the operating system in the base OS. By default, that first boot wizard that I referred to about, the ones when you first log in to your first instance, will download Firefox from FlatHub and set that up. Or you could use Chromium or whatever you wanted. It's a user's choice at that point, because you can go to FlatHub and get whatever applications you want. Alongside that, there is a really cool feature in DistroBox, which I'll talk about more later, where you can also, install or run graphical applications from containers. So, yeah, more about that later. And then above that, for command line applications, for developers developing stuff, for development environments, for VI and Nano, and all your favorite stuff there. We primarily on the MicroOS desktop use DistroBox, which is in essence a fancy way of running Podman containers with the intent being to have them interactive. So it's a nice user shell for you to play with. And that can be a distro box of any distribution of your choice. Obviously, Tumbleweed is the best, and I will explain why later. But this could be any distribution of your choice, and you can run any package from any distribution of your choice in your distro boxes or distro box, depending on how many you want. On top of that, so you can have whatever development environment you want. And if you want to run graphical applications, you can also export them so they can run as graphical applications in your shell as well. And then finally, on the right-hand side, there are classical applications, classical RPMs from Tumbleweed. You can install any Tumbleweed RPM that you feel like, be it a command line, be it a graphical application, be it something changing the base OS. But obviously, you're changing the base OS and it's modifying the base OS when you're doing that. So it's not recommended because the whole concept of this thing being consistent and known and moving from one clear state to another, we're not going to know what that state is if you're adding extra random stuff in there. So in plain and simple English, all graphical and terminal applications should be isolated from the base system. That's why we're using Flatpaks. That's why we're using DistroBox. Flatpaks are the main way of getting the graphical applications. DistroBox is the main way of getting the command line applications. And you can install any traditional RPM if you feel like it with transactional update. But as that can modify the base OS, we definitely discourage it as much as humanly possible. So, Flatpaks. Flatpak is a relatively new, a couple of years old actually, universal packaging format, primarily for graphical applications. So, you can argue that it's containerized, but it's not using, for example, like typically OCI containers or so Docker, Podman, etc. It's its own packaging format. It's focused and structured very much for the problems of graphical applications on Linux, which is good because we're talking about a desktop here, so it's a perfect fit. It's not just built for us though. Originally started kind of out of the GNOME project. There's lots of Red Hat and SUSE developers and lots of other distro developers who are working on it. And therefore it's built for every distro. That kind of distro neutrality is a big part of it. And every application, when it's delivered, is providing, a common platform, well, basically using common platforms of libraries or runtimes as they call it. So, for example, if you're installing a GNOME application, you get the GNOME runtime for whichever version of GNOME that application needs, and you get KDE runtime, etc. for KDE applications. So typically speaking, the way most open source developers are actually working, they're just picking the one runtime which fits everything they already need. All the libraries are already there. It's easier for developers to build the packages. It's easier for developers to distribute the packages. If they need to bundle their own stuff in, they can with Flatpaks as well. So the point basically being is no longer to software developers have to really worry about, telling, everybody in the open source world, if you want to install this, you need to install this, and this, and a million other things. Like, no, keep it simple. Common platforms, common packaging. You get the same package no matter which distribution you're on. Done. And then icing on the cake with all of that, of course, is because this whole thing is contained and bundled together. All these Flatpaks can then be run sandboxed and rootless by default. So, common basic security risks that we've all just kind of taken for granted of like, any RPM can do whatever the heck it wants when you install it. Like these problems don't apply to Flatpaks. Like, so, they're better than the basic format because they've been thinking about the problems that have been haunting us for the last 20 years. And this would be a cross section of what Flatpaks typically look like. You've got an application, it's in a sandbox. That application will probably have some data belonging to that application, config files, etc., whatever. There'll be the actual application code itself. It may have some runtime, some libraries that it needs itself to run, specific for that application. And then there is going to be a whole collection of shared libraries. This is what they call the runtimes in Flatpak. And so every application using the same runtime means you're not copying copies of those libraries all over the place. And then that's all inside the sandbox. So, for example, in a typical well-sandboxed Flatpak application, you won't even have access to files in your home directory. And then this is the function of portals, which are basically, codified, audited API holes poking through those sandboxes in order to provide things like the ability to access certain parts of the file system. So, if a sandbox needs to access your downloads folder, so your browser can put stuff in your downloads folder, there's a portal that's used for that. If an application needs to be able to open up a file dialog to read everything in your home directory, etc., etc. Portals are there to make sure that the controls are there to let things in and out. That also, of course, means that there are tools to even allow control of which applications can access which portals. So a bit like you see on Android and I think Apple as well, where you can add additional restrictions to applications. You've got similar levers and knobs now with Flatpaks as well. And so Flatpak is the packaging format, and FlatHub is the vendor-neutral app store, for lack of a better word, for a vast majority, the vast majority of Flatpak applications. Being vendor neutral, being sort of very upstream orientated, really, if you're packaging a Flatpak, unless you're doing something really weird and only doing it for like a very small subset of people, FlatHub is the place to go and put the application. Like, everybody should be having FlatHub on their machine if they're running Flatpaks. Why package your own? Why do it separately when you could do it all together with everybody else? Like, this is how open source works, right? We're better when we're all doing stuff together. So there's thousands of applications already there on FlatHub. There's even proprietary stuff there, so not just the open source stuff. Spotify, MS Teams, Minecraft, VS Code, all there. Some of those are packaged by community members contributing. The vast majority and the growing numbers are definitely, leaning more towards the upstreams themselves taking care of it. So, for example, like the LibreOffice Flatpak is handled by LibreOffice, which, even better, who's better to know how to package this properly and keep it running than the people who built the thing in the first place. And also has the nice benefit of this stuff comes bundled together with things like proprietary codecs when they need to come bundled with proprietary codecs. So if you need a bit of software to play a video, the video player in FlatHub is almost certain to have the codecs that you need. Whereas with distributions and the way distributions are licensed, that can be incredibly tricky for us to do. It's way easier for them to do it. So it solves a big problem that we've had in the distribution world for a very long time. On the MicroOS desktop, you basically see FlatHub by going to the GNOME software store. The only software source configured on the MicroOS desktop is FlatHub. So you see this nice collection of applications, split up into nice groups like creating, working, learning, developing, etc. This screenshot was taken a couple of weeks ago now. I'm sure there's a lot more new and updated than was there, but yeah, it's constantly being updated. There's constantly new things coming out. When you install them, it shows up in the installed section of there. As you can see, it's not using up ridiculous amounts of disk space or anything like that. My Chromium browser that I'm using to record this is 300 megabytes. Everything just installs there. If you don't want it, you then can click uninstalled. And with RM software configured the way it normally is, everything automatically updates itself. So when I took the screenshot, I didn't have any pending updates to show because it already updated itself 5 hours before. So yeah, automatic updates separate from the operating system, but still one less thing for you to worry about, again, fitting in with this whole MicroOS style mindset. And then when you are searching around for your applications, you get a software installation dialog like this. I wanted to kind of just highlight a few things that I thought were really nice to see. Things like the download size. Yes, this is all containerized, but of course, like I've mentioned, you're using those runtimes, so all those shared libraries it needs. In my case, this is a GNOME application. I already have the GNOME libraries on my machine, so this whole new application is just a nice small 2 megabytes. In this case of the Maps application, it doesn't need to access any of my data, it doesn't need to access my home directory or anything. So, the software tool here says exactly, it's safe. It can access my network, but everything's been audited and is auditable and clean, simple, done. So no risk there. There's an awful lot of applications there that have a yellow badge for that because, obviously a lot of applications need to be able to access your home directory to read and write documents and stuff. But that's the point. You see what the risk is before you install anything. That's awfully nice. Even has things like age ratings and if it's good for desktops or laptops or what have you, mobile devices, etc. Yeah, and so that's Flatpaks and FlatHub. Moving swiftly on to the geekier side of command line tooling. And as I mentioned, we use a tool called DistroBox. If you're familiar with SLE Micro or MicroOS or CoreOS or a lot of these immutable operating systems, you've probably heard a concept of toolbox. DistroBox was inspired by the same idea. So basically the core original problem is all these immutable operating systems have a read-only root file system. At some point, something's likely to go wrong. No matter how perfect we try and build these things, there's always going to be something that needs a little bit of poking around at some time. And debugging these systems is really quite tricky because if you have to install debugging tools, you then need to reboot for the installation to take effect, and then you've rebooted the system. Most of the time, that means you've also fixed the problem. So the idea was, you have these toolboxes. It gives you a read-write environment where you can install your debugging tools, and that read-write environment has the system in essence mounted, using the same process space, etc. So you can see what processes are running, do your debugging, and then throw the toolbox away when you don't need it. Well, in the context of something like the MicroOS desktop, it's not just a useful model for debugging. That's a really useful model for developers for actually a lot of the command line usage you would have on an old-fashioned Linux machine. Why mess with the base OS when you can just spin up a toolbox or DistroBox container in whatever operating system you want, with whatever languages you want, do what you need to get done, keep the container if you need it, or just throw it away and get a fresh one next time if you don't. So DistroBox has sort of really expanded on this idea and gone down that road of being, sort of the perfect interactive container box. That I haven't got a better term for it really. Environment. That's it. Supports any Linux distribution out there, as long as they have some kind of container to pull down. But I think almost every Linux distro these days does. Using Podman or Docker, of course, we use Podman, and using standard OCI containers behind it. Tightly integrates with the host OS, so like toolboxes, being able to show the other processes running in your user space, integrating into things like your home directory, external storage, USB devices, audio, graphical applications, etc. You get your read-write environment, which would otherwise be, a read-only system. So, you get your little read-write playpens to do whatever the heck you want in there. And in the case of the MicroOS desktop, we've actually built a custom tumbleweed container, which we call the DistroBox container. And that image is, already has everything DistroBox needs, all the additional bells and whistles that DistroBox needs to be able to do, like the hardware integration and the graphical environment integration, etc. So whereas you can pick any distribution that you want, when you do those distributions, you're going to have to download an image. The image is going to have to start. The package manager in the image is going to have to start. It's going to have to download a whole bunch of stuff from whichever repositories your distro of choice normally uses. That can take a couple of minutes. Fine. Once it's done, you're there and you've got your environment. And as long as you're not destroying the environment all the time, that's fine. But I didn't like that at all. So with the DistroBox container that we use by default, you get a tumbleweed image, it downloads the image, you're running, it's done. It's 10 seconds or less. So you can destroy those containers far more freely and not have to worry about waiting minutes to create a new one the next time around. So just kind of showing the problem in the real world as it happens. If you have a MicroOS desktop machine like this one, and for some bizarre reason you're one of those weird people that likes to run Nano, you try and run Nano and you can't run Nano because it's not installed, and you can't install Nano using Zypper because it's a transactional system and Zypper tells you about that, and you've listened to my presentation and said you shouldn't be modifying the base OS unless you really, really have to. Well, with DistroBox now you don't have to. All you have to do is run DistroBox enter. That will take all those defaults I just said, give you a tumbleweed container. Now, your tumbleweed container still doesn't have Nano because, I'm not crazy. I don't like Nano, so I'm not going to put it in the container for you. But if you like it, all you have to then do is Zypper in Nano. It goes to the tumbleweed repositories. It gets Nano. It installs it in there. And there you go. You've got Nano on your system. And as long as that container exists, so as long as you don't do like a DistroBox RM to clean up the container, that will always be there every time you do a DistroBox enter. So one thing that, for example, that I do on my systems is I actually configure my keyboard shortcut. So the keyboard shortcut that I would typically use for loading up a terminal doesn't actually load up my standard shell because I don't need it that much. By default, my terminal will just load up my DistroBox, and that's what I'm using every day for all my command line stuff. And then I have a different keyboard shortcut with the same keyboard buttons but with shift to give me the old-fashioned operating system desktop terminal when I need it. If you want, and you don't want to use the DistroBox container, there's nothing stopping you from building your own. You can easily take the openSUSE DistroBox one, rebase it, add your own libraries in, whatever. And on these systems, I showed DistroBox enter as the simple, easy way of doing it, but there is also the far more complicated DistroBox create command, where you can create as many different DistroBoxes as you want under as many different names as you want. So, if you're one of these developers that's like cursed with needing to support multiple different versions of Python, make one for one version of Python, using pip from that version, and then use another version of Python using pip from that one, and so on and so forth. No problem. Just, create those containers, pop into them when you need to use them, done. Or if you're not working on those kind of stacks, but working on distributions, well, DistroBox is, of course, awesome for that. You can have your tumbleweed environment alongside a Leap environment, alongside a SLE environment, and, you're going to be able to do it alongside an app environment soon too, all without needing to have VMs. So, if you don't need that VM isolation, why waste your time with it? And yes, like I already mentioned, if you want to use your DistroBox like a default shell in the GNOME terminal, it's incredibly easy to add a profile and just use DistroBox enter as the custom command instead of a shell command. One thing, of course, that I do an awful lot of, and I know a lot of people in the SUSE ecosystem do, is packaging in some form, either third parties and partners packaging RPMs for SUSE distributions, or SUSE developers building, or openSUSE contributors, whatever. We all kind of use a very similar set of tools. We all need to use OSC. We all need to use Git. Most of us use Vim, and in fact, OSC typically calls Vim for editing things like spec files and change logs, etc. And there's all these really cool OSC service plugins for pulling things from Git and various other source commands. And some of us who are doing release engineering also need like staging plugins, etc., or the openSUSE release tools. So I built a special distro box just for packages. So basically, anybody doing anything with packaging on the entire SUSE ecosystem. It's what I use on a daily basis. I think more and more of the SUSE and openSUSE release teams are using it as well. So there is the URL at the bottom, basically distrobox-packaging :latest. It's maintained exactly alongside the distrobox one, tested the same way, released the same way, always using the latest of everything, which also, of course, makes it really useful even if you're not using the MicroOS desktop, and let's say you're just using a different Linux distribution for whatever reason, or you're using Leap, and therefore you don't necessarily have the latest versions of all of this stuff. Well, you can install DistroBox on those platforms too, use that same container, still get moving with that, but of course you won't get all the cool benefits of having a nice MicroOS desktop underneath keeping your system stable. So as an example use, like I mentioned, there is this distrobox create command, which is the more complicated option instead of distrobox enter, where you can customize everything. And you have to give the container a name, and you have to give the container the image path, which is what I mentioned on the previous slide, that URL. And that's actually kind of it. I said it's complicated. It's not that complicated. If you want, you can also create the command as a root container. Therefore, the container will run as root. You only need to do that if you're going to want to use OSC build to do local builds, because local builds run in a privileged environment to try and isolate everything and make it reproducible and make it like we have in the build service. So if you're not using OSC build, you can drop the root command out of there. But once you've done that create command once for your one time, so in this case created a container called pkg, then every time you want to run and enter that container in the future, all you have to do is the distrobox enter pkg. So again, back to my examples with my keyboard shortcuts. I've got a keyboard shortcut for my regular distrobox, I've got a keyboard shortcut for that one, and I've got a regular keyboard shortcut for the regular terminal as well. And yes, distrobox export. So Flatpak has a huge collection, FlatHub has a huge collection of applications, and it's growing, but not everything is there yet. There's a lot of applications out there which, especially weird esoteric ones that, may only exist in, Tumbleweed, or may even exist in other distributions out there. So DistroBox actually has the ability of having an application that is installed in that container, then be exported. Basically, have the shortcut exported and modified, so the shortcut ends up in your desktop environment. So it looks like a normal application. You can click on it; it acts like a normal application, but in fact, it's running from the distro box. So incredibly simple to use. All you have to do is load up a distro box, install the application that would otherwise be missing, then use distrobox export. That will export the shortcut out of the container into your home directory. So therefore, it will then show, in your GNOME shell. And then, looks like a normal GNOME application. Clicks on it, runs like normal. You wouldn't really know it's doing anything. So this is great, especially if you've also got like third-party graphical applications, stuff that hasn't been ported into Flatpaks yet, or like I say, other distributions, Ubuntu, Fedora, anyone else who isn't doing the cool stuff we're doing here. If the packages only exist there, it's no problem at all to create a distro box, pop it in, export it, and away you go. So last but not least, when it comes to how to install stuff on MicroOS, on the MicroOS desktop, we have transactional update. At its heart, the whole concept of transactional updates is one more focused on updating the whole base OS. That's what it was originally designed to do. And thinking about this whole thing as the whole base OS, any change to a system should be applied reliably, reproducibly, and reversibly. So every transactional update is atomic. Either the entire update is applied or nothing at all, and it's all done in a single operation, so there isn't any chance for something weird to happen. And of course, this is all done in a way where, well, both applied without impacting the running system. So the update can happen silently in the background, and nothing's going to magically change underneath the system while it's running. But also inversely, the running system isn't going to impact the update either. It doesn't matter if some process is running, the transactional update should just be able to go and do its thing in the background and not be bothered by what else the user might be doing on their system. So that's transactional update generally. That's what you see in Micro and MicroOS and all the other micros. But on the MicroOS desktop, the transactional updates are also fully automated. We make sure that they're happening, entirely without you needing to configure or interactively do anything. By default, that's happening daily, either between midnight and 2 a.m., if your desktop happens to be on at that time, or more realistically, assuming your system was off between midnight and 2 a.m., the updates will be applied within 2 hours of the latest boot. Basically, it picks a random time from the first boot and does it then. The reason we do not do it exactly at first boot is, of course, well, that's when your system is almost certainly at its most busiest. It's just booting up, it's running everything. And you just turn your computer on. It's a pretty fair assumption that you want to do something too. So even if the system isn't busy, you're going to be busy. So just to make sure that we're not stomping on that at the worst possible time, we pick a random time within the first 2 hours, and then it'll happen quietly in the background. And then when those updates happen, unlike on SLE Micro and MicroOS, where obviously in a server concept, if you're going to have fully automatic updates that only apply when there's a reboot, then you want to have those fully automatic reboots happening also. In a desktop environment, that doesn't fly. The user needs to decide when to reboot. So the updates happen in the background, and then you get a notification on your desktop saying, there's an update pending, please restart. Unlike other sort of offline update processes you might see in things like Fedora, of course, one of the key sort of human benefits of this, not just like the stability of, and how cool and clever all this stuff is, but like in simple human terms, Fedora have an offline update process where you might also need to reboot to apply an update. But in their case, the update happens on that next boot. So your next boot takes 10, 20, 30 minutes, whatever, just like Windows, right? Like the update doesn't happen until it's booting, and then it's happening in the boot environment. Well, with transactional updates, the updates happen. Everything's been done and processed, so the reboot will take as long as a normal reboot will take. And you're not spending a whole bunch of wasted time rebooting your system. If your system normally boots in 20 seconds, this should also boot in 20 seconds. That's the point, keeping the whole thing reliable and reproducible. So, as I've said a few times, you can use transactional updates to therefore modify the base OS. If you want to add or remove packages from your MicroOS desktop base, all you have to do is transactional update pkg in and then the package name, or rm to remove a package. Yes, that's a bit of a long, clunky string. No, we're not going to make it shorter because, we don't really want to be encouraging this. It's there for when you need it, because there's going to be times you need it. If you're using it every day, you're probably doing something wrong. In, of course, some cases, some software doesn't come as nice, simple packaged RPMs. Some drivers end up having really nasty shell scripts or something to run instead. And in that case, you don't have to use the pkg in command. You can use the run command instead. In all these cases, what is basically happening is transactional update is creating a BTFS snapshot in the background and then doing the change in that snapshot. All of the examples that I've given here are in essence one shots. So if you do a package installation, it'll create a snapshot that just does the package installation. And if you don't reboot and then do another package installation, you're going to have another snapshot that just does that other package installation. So, the whole idea again of keeping things consistent and not moving and mixing up states of how a system could be. If you do want to sort of chain a whole bunch of commands together, you can do a transactional update minus minus continue. So you could, install one package, install another package, install another one, as if you'd all done it in one command and then reboot. But yeah, fitting in with the mindset, this is the simple way of thinking about it. And of course, the disclaimer goes again, but I'm just going to keep on saying it. Tinkering with the base OS can make things way more unreliable and way trickier for us to debug. So please try your best to avoid it when you can. Flatpak and distro hotbox is there for the vast majority of cases. This laptop here, for example, I don't think has anything that has been installed by this way, and it's been running for a couple of years now. If something goes horribly wrong and you do use it and you did need to use it and then it's all broken anyway because, that reliability went down the wrong way, or in the very unlikely chance that we've done something wrong and rolled out a bad update and rolled it out in a way that doesn't automatically heal, then all you have to do to roll back the MicroOS desktop system is run transactional update rollback last. That'll roll it to the last known good. In the the astronomically tiny chance that your last known good wasn't actually good, which, but I'm paranoid, so I'm going to put this here anyway. You can still use Snapper to list all of the snapshots that your system has, and then you can use transactional update rollback to roll back to a chosen number that you want. The reason you can't use Snapper for doing the rollback is transactional updates on a MicroOS system has extra handling for things like rolling back the configuration, which Snapper can't do. So, if you did a Snapper rollback, you potentially roll back the base OS and don't roll back the config, which potentially means you end up with a more mess than you otherwise would. So, transactional update is the way to go to roll back any MicroOS system, not just the MicroOS desktop. And so, the future. One wonderful problem of the popularity of MicroOS and SLE Micro has been there's this ongoing proliferation of micro distributions in the SUSE ecosystem. We have MicroOS and we have Leap Micro and we have SLE Micro and we have the MicroOS desktop and we're going to have Out Micro in the future. And they're all awesome and they're great. And every single one of them is a server operating system apart from the MicroOS desktop. And going back to the earlier slide, right? Desktops are different. So the MicroOS desktop has, constantly been diverging from Micro, taking the same concepts, but, just because the platform's different, we have to do things differently. And so, Micro desktop is the odd one out, but at the same time, because it's a desktop operating system, we're grabbing a very enthusiastic user base and it's growing very well. And lots of people are on the internet, on forums and Twitter and so on, talking about how they're running openSUSE and MicroOS when, well, they are, but, they're running the desktop one. They're not running, the server one that everyone else is actually working on and building. And, so the confusion gets a little bit crazy. Especially when, dealing with bug reports and the like of I'm running MicroOS, and then we're like, which? So one thing that we decided to do is basically look at a new name specifically for the MicroOS desktop because it's the odd one out. And there was plenty of names thrown around. But in the end, after long discussions with the community, we sort of hit upon this concept of Eon. We're a rolling release. We're trying to be as stable as possible, as reliable as possible. The idea is you can deploy this thing and keep on running it forever. It's meant to be the most powerful desktop out there. So you take the dictionary definition of Eon and you realize, this fits what we're doing. So I've spent this entire presentation talking to you about the MicroOS desktop, but in fact, I've really spent this entire presentation talking to you about openSUSE Eon because that's the new name for the MicroOS desktop. There's going to be no major technical differences. The whole point of this transition is the MicroOS desktop will seamlessly migrate to Eon. So you can download the MicroOS desktop today. You can, install it. When the new name goes online and things slightly change there, your system will migrate seamlessly between it. One of the things that I'm using kind of as a luxury of because I'm doing this at the time where things like ALP is coming up on stream, taking some of the build concepts and methods that we're using for SUSE ALP and using it as the model for building openSUSE Eon. So, the modularity of how we build things, having a different code stream, which of course in this case is still going to be Tumbleweed, but having the flexibility of how we build things and do things is something that I'm having great fun with at the moment. That also means being able to have great fun with things like using a gamma and full disk encryption as part of an installation method. I'm experimenting with that right now. I was hoping to get it ready for SUSECon, but unfortunately haven't at the time. But in fact, if you're watching this at the conference, I will actually be there at the openSUSE booth demoing this, so you'll be able to see the prototype version where this all works. And that's the future for the openSUSE MicroOS desktop. We're moving forward with it as Eon. I'm expecting the first sort of formal proper release out in September, but like I say, right now you can download the MicroOS desktop. It'll work the same way anyway. It's got its new name. We're building a new website for it. There's the wiki page there, which in fact, if you click on that old URL, because I had to get these slides finalized before the new one was ready, that will redirect you to the new URL. So please feel free to join in with the community. We're all volunteers doing this. It's entirely community driven affair. Please join us, make it more of a success. Let us know what we can do better. Send me pull requests, and have a lot of fun. So, thank you very much.